is Iready Practice and Problem Solving, page 225 and 226. There is a lot of explanation on the first page, so I'm not going to cover it. These questions, if you will read this information at the top and kind of go through their thought process, I think you can answer those questions pretty easily. I am going to spend my time here because here's where some of the harder problems are. So on number 4, Donna bakes biscuits on a rectangular cookie sheet that is 30 centimeters by 50 centimeters. So here's my cookie sheet. It's 30 centimeters by 50 centimeters. Each biscuit has a diameter of 8 centimeters. So that means that across the center of the biscuit is 8 centimeters. What is the maximum number of biscuits that Donna can bake at once on the cookie sheet? Well, 3, if you've got 30. You need to divide 30 by 8 centimeters to see how many biscuits I can put on that end. So 8 times 3 is the closest you can get because 8 times 3 is 24. So I can put 3 biscuits this way. Then you say 50 divided by 8. And let's see, what's the closest you can get there? 8 times 5 is 40. 8 times 6 is 48. So it's going to be 6 this way. 1, 2, 3, 4, 5, 6. So then, of course, you can tell now that 6 this way and 3 this way means that I can put a total of 18 biscuits on my cookie sheet. So 18 biscuits. If Donna bakes the maximum number of biscuits, what area do the biscuits take up on the cookie sheet? And explain. Well, okay, the maximum number would be 18, right? So I would need to say 18 times the area of a biscuit, of one biscuit, right? So if the biscuit, it tells us the biscuit has a diameter of 8. Well, to find the area is pi radius squared. So I'm going to use 3.14 for pi. Half of 8 means that this thing has a radius of 4. So 4 squared times 3.14, that would be 3.14 times 4 times 4, which is 16. So let me open up my calculator on my phone. I'm going to go 3.14 times 16, and that gave me 50.24 is the area the biscuits would take up. So now that I know what the biscuits take up, then I need to find the amount of the cookie sheet. Well, it's a 30 by 50. So it was 1,500, right? Square centimeters. Oh, I'm sorry. All it's wanting is 50.24 because times, that's the area of one biscuit. So then I'm going to multiply that times 18 biscuits. So I would say 18 times 50.24, and my final answer is it's going to take up 904.5 centimeters squared. I think I wrote that down wrong. If you do 18 times 50.24, you get 904.32 centimeters squared. So let's put that. 904.32 centimeters squared. This next problem is interesting because it looks like, when you first look at it, I think a lot of students will think that there is not enough information. But it wants us to find the area of the unshaded part. Well, I need to find the area of these circles and then take them out of the area of the rectangle. Well, there's several things that you might notice. One is I don't have this length, but that length is the diameter of that circle. So the diameter of the circle, these are all equal circles. There's 4 diameters. So if I say 20 divided by 4, I realize that the diameter of these circles is 5, because 5 times 4 is 20. And when you divide 20 into 4 equal parts, you get 5. Therefore, the radius halfway would be half of 5. What's half of $5? $2.50. So the radius is 2.5. Now, I just take area formula, which is pi, we're going to use 3.14, times the radius squared, 2.5 squared. Well, when I squared 2.5, I would say 2.5 times 2.5, and that gives me 6.25. Then I multiply that by 3.14. That's going to give me the area of one circle. So 6.25 times 3.14, I got 19.625 for one gray circle. I need to multiply that by 4 to get the area of all 4 circles. That gave me 78.5. Now, I'm not finished because I need to find the area of the big rectangle, which is a 5 by 20, because remember, the diameter would be that way also. So I would do 20 times 5, which is, of course, is 100, and I would take 100 away from the area of the circles, which was 78.5. My final answer, the unshaded part, is 21.5 inches squared. Let me make sure I type that in right. It's always good to double check yourself. So I'm going to go 2.5. That's 6. That's correct. Okay, so let's go on to the next problem. A circular garden has a diameter of 6 feet. There are 2 sections of blue flowers and 1 section of white flowers, as shown. What is the area of the section with the white flowers? So the first thing you need to notice is that the line I have drawn across here shows the diameter of the entire garden, which it tells us is 6 feet. Now, I need to find the diameter from here to here. Well, I would take out 2 1-foot pieces, and it means that the diameter is 4 feet if I'm just looking at this part. So I'm going to find the area of that circle, and then I'm going to subtract out the area of the little blue circle in the center. That's what I'm thinking they're wanting me to do. So first, I'm going to start by finding the area of a circle that has a diameter 4. Well, if the diameter is 4, the radius is 2. So it's going to be 3.14 times 2 squared, or 3.14 times 4. Well, that gives me 12.56 for the radius of the whole thing, the white circle. Now I'm going to find the area of this blue part here. Well, it tells me that it has a diameter of 2 feet, so that means it's 1 squared times 3.14 to find that radius. Well, then that's going to be minus 3.14, because 1 squared is 1, and 1 times 3.14 is 3.14. So once I subtract that out, that gives me 9 Alright, so I've done a lot of the problems for you on this sheet, so it should be real easy for you to get credit for this one. Have a good day. I miss you guys. This is already practice